Hey guys, welcome back. How are you? I hope you are good and doing well. In the last lecture, we discussed about the divide and conquer algorithmic approach in general, and now in this lecture, we will look at the practical use case for divide and conquer approach. Okay, and we will look at this with one of the most powerful and popular sorting technique, which is quicksort. So, quicksort is another in-place sorting algorithm, and that is mainly based upon the concept of divide and conquer algorithm. Okay, rather than directly sorting the array, it first choose a pivot element and then it does the partitioning of the array based on the pivot element, and it partition the array recursively. Okay, it keeps partitioning the array recursively unless the sub problem meet the base case, and once it happen, it sorts the array in the base case. Okay, but the main thing to remember in the quick sort is the selection of the pivot element, because this is a very crucial step that significantly affect its performance. Okay, the simplest approach is to choose the first or last element of the array as the pivot element, but it has more chances to lead the worst case performance if the array is already sorted or reverse sorted. Okay, the best case approach for selecting the pivot element is either use the randomized quicksort, where you can select any random element from the given array as the pivot element, or you can choose the median of the array, I mean the middle element of the array. Both provide the more balanced approach for implementing quicksort. Okay, and the pivot selection is really important because it's the pivot element which makes sure that the all the array elements which are lower than pivot must be in the left to the pivot, and all the array elements which are greater than the pivot must be right to the pivot element. Okay, so this is a very basic and theoretical detail about the quicksort. Okay, so few things you need to remember in the quicksort: that first you have to decide your pivot element carefully. Okay, once you decided the pivot element, what you need to do as the next step, that all the elements which are lower than the pivot element must be come left to the pivot element, and all the larger element than pivot must be in the right of the array. Okay, so now let's implement the function to implement the quicksort in a given array. Okay, so here you can see that this is our sorting class. Okay, so here we already implemented the bubble sort in both not in place and the selection sort. Okay, and now we will implement the quicksort implementation here. Okay, so def quicksort array. Okay, so here we will accept some argument as the array. Okay, now first we need to assume that if the array length is 0 or 1, then we no need to make any recursive call because one element array is always sorted. Okay, in this case we can simply return the array. Okay, so here first line what we need to do in the quick sort, that return array if array dot length is either 1 or less than 1. Okay, so if array dot length is less or equal than 1. Okay, now what we need to do, we need to do for further, now we need to define two empty arrays and name these arrays either as the left array or the right array. Okay, and the right arrays. Okay, so in the left array we need to store all the elements which are lower than or equal to the pivot element, and in the right array we need to store all the elements which are higher than the pivot element. Okay, so let's define left comma right equal to these two empty arrays we can assign to the left and right arrays. Okay, now we need to iterate through each array element. Okay, why we need to iterate through? Because we need to put some element into the right array and some element into the right array which are greater or higher than the greater or lesser than the pivot element. Okay, but first we need to randomly select the pivot element. Okay, and take that pivot element out of the array. Okay, so what we can do here, pivot equal to array dot delete add. Okay, and then rand array dot length. Okay, so here you can see what we are doing for the pivot element, that we are making pivot equal to array dot delete at any random index. Okay, so we are deleting that pivot element from the array. Okay, now we need to iterate through each array to fill the values within the left and right arrays. Okay, so here what we can do, array dot h2, and then here element, and then if element is less or equal than pivot, if element is less or equal than pivot, then what we need to do, we need to insert that element into the left array. Okay, so left, sorry, element. Okay, else what we need to do, we need to insert the element within the right array. Okay, so here you can see what we did so far. So here at this step we decided what will be our pivot element, and we use this random function. That means we are randomly selecting the pivot array from the array. So what, it could be anything, like it could be first or last element of the array, or it could be median of the array, or it could be any array element that we can select at the pivot. Okay, however, still if the random selection give first and last array, it can lead to worst case, but still it's a balanced approach. Okay, because you are not going to have first and last element all the time, it is decided randomly. Okay, so it is a balanced approach. Okay, so and after deciding the pivot, what we are doing, that we are iterating through the array element, and all the element which are either less or equal than pivot element, we are inserting them into the left array, and then if they are not or greater than the pivot element, we are inserting them to the right array. Okay, now we need to make some print to log the steps in the quicksort. Okay, so after this iterator, what we need to do, let's say puts pivot element is, let's say, make it like pivot. Okay, and why I'm doing that, because in each recursive call, because after this print statement we're gonna call this quicksort method recursively. Okay, so using this statement we can have log that in each recursive call what will be the pivot element, and what will be the left array, and what will be the right array. Okay, now what we need to do here, that print, then left of the pivot is, and then simply you can do is here left. Okay, and then just copy this, and after this to print new line character. Okay, and here right of the pivot is, okay, and then print a new line character. Okay, now we need to return the element, and in the return statement we will call this function recursively. Okay, so here what we need to do, return start quicksort, and then first we need to pass left array. Okay, and then pivot. Okay, and then quicksort, and it will be the right element now. Okay, so here quicksort left and quicksort right are making the recursive call. Okay, now let's use the same array that we have here. Okay, and now what we need to do, we need to test our quicksort function. Okay, so save everything, and just copy this quicksort function. Okay, so copy this and go to the Rails console or some IRB console. Okay, paste this here, and now go to the file again and copy the same array. So copy this array, paste it here, and now what we need to do, we need to call our quicksort with this array argument. Okay, quicksort and then array. So when you run this, you can see that we are getting the sorted array at the last element, but here you can see that the what is the pivot element. So for at the first step, the pivot element is chosen as the 56. Okay, so here you can see that we have this random element as the pivot element, and here you can see that this is the left of the pivot element and this is the right of the pivot element. Okay, so and at the next step, when this quicksort is called with this element, the pivot element is 4 and then it's 4 3 2 and then 6 4 and so on. So here you can see that at every recursive call our pivot element is different and we are getting the left and right array as well. And here you can see that when you get this, okay, your call will be decided with this and this array, I mean the left array, and then next time the pivot is 4 and then this is your left array and then right array. So you can see here that quicksort is working fine. Our pivot element selection is random and we are uh, balancefully dividing the array into the left and right based upon the pivot elements value. Okay, so our quicksort is working. Okay, now there is one more improvement we can do in our quicksort implementation. So just open this quicksort method. Here you can see that we use iterator to compare each array element with the pivot, and then we are deciding that whether this element should go into the left array or should go into the right array. Okay, but what we can do, that we can use array.partition, I mean the partition method which is provided by ruby array. Okay, and with that partition method we can avoid this step. Okay, so here what we can do, we can just remove it, or for example better comment it, and now define your pivot array over the left and right. Okay, and then here what we can do, that array.partition, and then here what you need to do, element, and then element is less or equal than pivot. Okay, so now you don't need this step. Even if you wish, you can remove this as well. So what this line is doing, okay, this line is making the partition based upon this condition. Okay, so at the first step you are deciding your pivot element, and after deciding the pivot element, what you are doing, that you are calling the partition method to partition the array into two parts, and all the elements which are less than the pivot or equal to the pivot are in the left array, and all the elements which are greater than the pivot are in the right element. Okay, now let's call this quicksort again with this partition method. Okay, so just copy this and paste it here, and then just use this array as well, because since quicksort is in place, so now our array has been modified. For example, if you see the array, okay, still it is, do it like that, and now call the quicksort, and what you need to do here, array, call this array, and you will still see a sorted array. Okay, so here what we can say, that using this partition method our approach is more better now. Okay, and if you wish, after testing you can remove these print statements from here as well. So now it's very cleaner, so you can see that it's very short implementation of quicksort and better implementation of quicksort. Okay, so this is how you can implement quicksort in the ruby. Okay, however there could be many more approaches as well, but make sure about quicksort that first you need to make you need to decide your pivot element. After that you need to decide, or you need to partition the array into left and right, and then you must make recursive call to sort the array. Okay, and this way you can see that at this place what we are doing, we are choosing the pivot, and this place what we are doing, we are dividing our problems into multiple smaller sub problems. Okay, and this recursive call is solving each smaller subproblem at a time, and when it returns the entire function, it is just combining that solution and providing you the final result. Okay, so this is how divide and conquer works in the quicksort. Okay, and this is how you can implement the quicksort. Okay, so if you wish, you can just keep it as well, and now let me show you the complete solution. So whatever way you want to do. Okay, however if you can do it like this way as well. Okay, so this is commented. Okay, so this is one way to partition the array, or short and simple is use the array.partition method to partition the array. Okay, and then you can implement the quicksort. So that's all from this lecture. I hope you found it, you like this and found it helpful. So thanks for watching this, and we will meet into the next lecture. Till then, tata, goodbye, take care, stay safe.